Hi everyone, welcome to lesson 20 of the Advanced Higher Stats course. In this lesson, we will be looking at most of the normal distribution hypothesis tests. Here are the tests that we will be covering in this video. If they're not covered in this video, they will be in another video about hypothesis tests. Some assumptions we make to do these tests are that the sampling method was truly random, the observations were independent, and the population distribution is normal. We'll start off with a one-tailed test for population means. A researcher claims that the average commute time in a city is less than 25 minutes. To test this claim, a random sample of 30 commuters is taken, the sample mean is 23 minutes, and the population standard deviation is known to be 4 minutes. Conduct a one-tailed hypothesis test with a 5% level of significance. We start off with H naught being mu equals 25, the true average commute time is 25. And the alternative hypothesis being mu is less than 25 minutes. The reason we can do a z-test in a normal distribution is that the true standard deviation is known, sigma is known, and the sample size is greater than 20. If that wasn't the case, then we would be doing a t-test. We get our critical value, which is 1.64, and then we get our z value, which is 25 minus 23, or it could be 23 minus 25, it doesn't really matter, over sigma over root n, and that's not there, and that gives us 2.74. 2.74 is greater than the critical value. Therefore, significant evidence at 5% significance to reject H naught and suggest the average commute time is less than 25 minutes. That would be our conclusion. Next is a two-tailed test for population means. A company states that the average weight of their cereal boxes is 500 grams. To verify this, a random sample of 25 boxes is collected. The sample mean is 495 grams and the sample standard deviation is 10 grams. Perform a two-tailed hypothesis test at 1% significance. So the first thing we do here is we write our hypothesis. The null hypothesis is that mu, which is the average weight of the cereal boxes, the true one is 500 grams. The alternative is mu is not 500 grams. Again, we can do this test because we know that the sample size is greater than 20. We may not know that the standard deviation, the true standard deviation, but as long as the sample size is big, we can still do a z-test. Our critical value for this will be 2.58. And now we find the z value, which is 500 minus 495, or it could be the other way around, it doesn't matter, over 10 root 25. And that gives us 2.5. 2.5 is less than the critical value, therefore not enough evidence at 1% significance to reject H naught and suggest the average weight of cereal box is not 500 grams. Next is a one-tailed test for population proportions. A manufacturing company claims that 80% of its products meet the quality standard. To test this claim, a random sample of 100 products is taken. 78 of them meet equality standards. Perform a one-tailed hypothesis test at 5% significance. Okay, so P hat is 0.78 and Q hat is 0.22. The reason we can do this test is because NP is greater than 5 and NQ is greater than 5. We write our hypothesis. So the null hypothesis is that the true p-value is 0.8. The alternative is the true p-value is less than 0.8. The critical value, so it's 10% significance, so it will be 1.28. And now we find the z value. Z is equal to the difference between the true p-value and the sample p-value. That's 0.8 minus 0.7 over the standard error, which is root pq over n, sample p sample q over n. So that should be 0.8 minus 0.78. So standard error should be 0.78 times 0.22 over the sample size, which is 100, and that should give us 0.48. And since 0.48 is smaller than the critical value, therefore not enough evidence at 10% significance to reject H naught. And suggest less than 80% of the products meet the quality standards. Now it's a two-tailed test for population proportions. A political poll suggests that 35% of voters support a particular candidate. To verify this claim, a random sample of 200 voters is taken. Among them, 68 express support for the candidate. Conduct a two-tailed hypothesis test at 5% significance level. Okay, so what we're testing here is, first let's find a p hat and the q hat. P hat is 0.34, q hat is 0.66. H naught will be the true p-value is 0.35, and H1 is the p-value. The p-value is not 0.35. The critical value for this two-tailed test is 1.96. And now we find the z value, which is 0.34 minus 0.35. Or the other way around, it doesn't matter, over the standard error, which is 0.34 times 0.66 over 200, all rooted, which gives us 0.3. Since 0.3 is greater than the critical value, therefore not enough evidence at 5% significance to reject H naught and suggest 35% of voters don't support the candidate. Now we move on to difference in population means. A researcher wants to determine if there is significant evidence that Group A students on average do better in tests than Group B. The sample sizes are both 30, with Group A having a mean of 85 and a standard deviation of 10, and Group B having a mean of 82 and a standard deviation of 12. There are two ways of doing this. You can write out the individual distributions, get a difference, find a z value from that distribution, and see if it's better or worse than the critical value. Or you can use this formula here on page 6 of the data booklet, which I personally find is easier. So before we even write a hypothesis, we should probably tell our markers what is 1 and what is 2. So what is 1 here and what is 2 there. And how we'll do that is 85 is equal to x bar 1, 82 is equal to x bar 2, and they'll be able to figure out if which standard deviation is what. Not that it matters because the sample sizes are the same, but that'll be fine. Next is our hypothesis, which is, I do an arrow this time because what we're doing is mu1 minus mu2 is equal to 0. So if I had a minus instead of an arrow, it'd be a bit confusing. That's why. We're doing mu1 minus mu2 is equal to 0 because we're assuming there's no difference right now. That's the common belief. What we're trying to prove that there is a difference. So mu1 minus mu2 in that case would be greater than 0. Our z value, since we aren't given a z value, we always go for 95% confidence or 5% significance, which is 1.64. Then we find a z value, which is x1 minus x2, so 85 minus 82, over the standard deviation of 1 squared over the sample size, so 10 squared over 30, plus 12 squared over 30, all square rooted, which gives us 1.05. Since 1.05 is smaller than the critical value, therefore not enough evidence at 5% significance to reject H0 and suggest group A students on average do better tests than group B students. Next is difference in population proportions. An educational program claims to increase the graduation rate. To test this claim, a random sample of 200 students who participated in the program and 200 who did not is taken. The graduation rates are 72% and 65% respectively. Conduct a one-tailed hypothesis test at 5% significance. So, first what we need to do is find a p hat and q hat, but since we're dealing with two p-values and two q-values, what I like to do is have the number as well. So p hat 1 is 0.72, p hat 2 is equal to 0.65. That means q hat 1 is equal to 0.28, and q hat 2 is equal to 0.35, and n is 200 for both. Our hypothesis would be, or null hypothesis, would be that P1 minus P2 is equal to 0. And our alternative would be P1 minus P2 is greater than 0, since we're seeing if the educational program increases the graduation rate. They could also ask you for two-tailed, but I won't be covering that since that's already been covered in the previous test. The critical value is 5% significance, which is 1.64. And now we move on to finding the z value. But before we find the z value, we have to calculate this p-value here, which is not p1 or p2. So let's do that first. We'll do that down here. So the normal p is equal to 200 times 0.7872 plus 200 times 0.65 over 200 plus 200 which gives us 0.685. That means our Q will be 0.315. And now we can find the Z value. Z is equal to P1 minus P2, so 0.72 minus 0.65 over PQ, the normal PQ, so 0.685 times 0.315 times 1 over 200 plus 1 over 200, all square rooted, which is 1.51. Since 1.51 is less than the critical value, therefore not enough evidence at 5% significance to reject H0 and suggest the educational program increases graduation rate. That is the end of the lesson. Now you should know all of these hypothesis tests.